Hi everyone! Welcome back to Fast Cabling, where we break down the complex tech and make it simple and fun. Today, we are diving into fiber optic network expansion, especially how you can do it easily and cost-effectively using optical splitters. So imagine you've already got a fiber connection, but you need to expand it to multiple points. So let's explore the best way to make that happen. Also, if you're planning to expand your fiber optic network or have any tech challenges that you need help with, we are offering free tech consultation to all of our viewers. So we're here to help you figure it all out. So with the growing demand for faster and more reliable internet, the need to expand existing fiber networks is skyrocketing. Whether you're an ISP, managing an enterprise network, or overseeing a large campus environment. But what happens when you need to send that fiber connection to multiple locations? Now here enter optical splitter. Now these passive devices are game changer. In simple terms, an optical splitter allows you to take one single fiber line and divide it into multiple lines and delivering the same high-speed connection to different locations. So it's an efficient and cost-effective solution for network expansion, especially when compared to traditional methods. Typically, if you want to expand your fiber network, you'll rely on a setup that looks something like this. You use a fiber switch at the control center, and then media converters at each of the edge locations to convert the fiber signal back to something usable like Ethernet. While this works well, it comes with some downsides. First off, cost might add up quickly if you have many devices. You need multiple fiber runs and all the necessary equipment like fiber switches and many media converters, which can get expensive. And then there's the complexity. Managing multiple fiber switches and converters at different locations adds an extra layer of difficulty, especially when troubleshooting. Not to mention the power requirements. These active components, like media converters, need constant power, which adds to your operational costs and can make installation in remote areas tricky. So now, here's where the optical splitters shine. They're passive, meaning they don't need power to function, just light. And one single fiber connection from your control center can be divided in several lines, and boom, you're connected to multiple edge locations. So now let's break down the main benefits. First, cost effectiveness. You need fewer fiber runs and way less equipment. Second, the setup is super simple. Since splitters are passive, there's no need for extra power at the edge locations. Third is space saving. You have a more compact installation, especially at the edge. And lastly, scalability. You can easily expand the network in the future without needing major upgrades or tons of new hardware. So now you're looking at the complete setup. Let's talk about how it works. First, a single fiber string will enter to the optical splitter, which then divide that signal into multiple paths. Now you can have splitters with different ratio, like 1x8, 1x32, and even larger, like our 1x64, depending on how many endpoints that you need to connect. And now, let's walk through the installation process. It's super simple, straightforward, and I'm going to show you exactly how to do it. So step 1, choose the right splitter. First, you need to select the suitable splitter based on the number of devices or endpoints that you want to connect. For example, if you're connecting 30 endpoints, you should go for a 1x32 splitter. And if you're installing an outdoor, you can opt for an outdoor waterproof type. So now you're looking at our 1x64 splitter. As you can see, this is passive, so there's no need for power supply. Now I'm going to connect the single fiber string from the control center. Now today we are using this 2-string pre-made fiber optic cable, so we don't have to worry about the connector. just plug and play. Let's use string A. Enter it to the input port. And then we have so many output ports that we can select from. Let's choose this one. And then using another fiber optic cable to connect it to your endpoint. And next, let's connect the main fiber string from our splitter's input port to our optical line terminal, or you can call it OLT. Now think of the OLT at our control center that can manage your entire network. So this is the same fiber optic cable. Remember, we use string A. So let's connect it to our OLT. And to the PON port. And now we can take the output fiber string from the splitter and run it to the ONU, optical network unit at the edge. Now ONU is a device at the edge just like your Wi-Fi access point, where the fiber is converted into a signal that your device can use. So this one here is a Wi-Fi ONU. That means it can distribute Wi-Fi signal directly. So now let's get our fiber optic cable and plug it directly into the PON port. And let's turn it on. So the setup is completed. And there you have it. Expanding your fiber optic networks with optical splitters is simple, cost-effective, and scalable. Whether you're an enterprise, an ISP, or managing a campus network, this method makes it easier than ever to grow without the hassle. Now, thank you very much for joining us at Fast Cabling. Before you go, please don't forget to like, subscribe, and drop any questions in the comment section below. And I'll see you in our next video.